Okay, you guys, the name of the game today is just we want to be able to find the zeros of any polynomial function of any degree. And so a couple things we're going to talk about here are pretty important when we try to find these zeros. But basically, if a polynomial equation is of degree n, okay, so we have an nth degree thing, then it says then counting multiple roots separately. That means just like if you get the same answer 3 times, it counts as 3 separate answers, not the same answer, 3 different times. So, but if you count those separately, then the equation has exactly n roots. So what this means is f of x is degree n, then there are n solutions. And this is always true. And the other thing is this, if a plus bi, which is a complex zero, okay, if a plus bi is a root of a polynomial equation with real coefficients, then we would say that the imaginary number a minus bi is also a root, so long as the b part here isn't 0, so long as it's not just a, okay. So we say that complex zeros come in conjugate pairs. So complex zeros come in conjugate pairs. So knowing these two things, we're going to keep them in mind when we go and find some zeros here. But this one here, again, means this implies that this has to be a 0 also. But basically, we're just going to go find the zeros of these. And you'll notice that some of them may be factorable, but we're going to start to look at things that aren't factorable. And the goal will be to use division to help us kind of factor these. So really quickly here, let's read through the instructions. List all possible rational zeros. Use synthetic division to test them. And then use the quotient from part B to find the remaining zeros of the function. So with respect to number 9 here, the first thing we'll always do is make this list of possible rational zeros here. And this looks familiar. This was just like the first one we did in the last video here. We say that the factors of 4 are 1, 2, and 4, and the factors of the leading coefficient 1 are just that. So we would say this list reduces down to 1, 2, and 4. And so basically, I don't know which one of these is going to work. Essentially, what I want you doing today is this. If you have a graphing calculator on you, and you should, then I want you to go and graph the function. So we would get x to the third plus x to the second minus 4x minus 4. And what I want you looking for are, do any of these zeros here appear on our graph? And so it looks to me like -2, -1, and +2 all work here. Usually I would tell you of this list, we would just go and divide by 1 first, but I can see that 1's probably not going to work here. Maybe I'll try 2 first. So we'll put a 2 out here, and we'll run some division on this. Now, one thing I want you to keep in mind is this. If 2 is a solution, then the y value we get at that x value here, it should be 0. And the other way of saying this is that the remainder, okay, remainder is 0 if dividing by. Now here's the thing, if x equals 2, then our factor would have been, the thing we were dividing by would have been this here. So if this is a 0, then it goes in and the y value is 0. But also, if this is a 0, then x minus 2 must have been a factor. And the neat thing about that is this will be the other factor here. Okay, so we'll go ahead and drop down our 1. 1 times 2 is 2. Let's see, did I get my coefficients in here right? We say 2 plus 1 is 3. 2 times 3 is 6. 6 plus -4 is a 2, and 2 times 2 is a 4. So we do indeed get 0 for a remainder. And the thing I want you to see is that this third part says use the quotient from part B to help us find the other zeros. And what I want you to understand is that the original polynomial, okay, if I were to write it as the quotient that I got, x squared plus 3x plus 2, times the factor that I divided out, the thing I was dividing by, which was x minus 2. This right here would have to be the same thing as what I started with, because when you take what you get when you divide times the thing you were dividing by, you get back to what you started with. So part C here, here's going to be the trick today. We're going to keep dividing and dividing and dividing and dividing until we find something that goes in evenly. But once you do that, this leftover quotient, what I want you to do is I want us to go set it equal to 0 and go solve it. And in this case, we could just solve it by factoring. It'd be x plus 2, x plus 1. And so setting these factors equal to 0, x plus 2 equals 0, or x plus 1 equals 0 here, then we get x equals -2 and x equals -1. So in terms of our zeros here, we found 3 zeros. We found -2 and -1, and then we found 2 up here. We would want to list those. We say our zeros, or our roots, are x equals negative and +2 and -1. Okay. So the idea is going to be this. You're going to make your lists. divide till you find something that goes in evenly, and then use that quotient that's left over, if it's second degree, to either use the quadratic formula or factor it to solve it. And some of these you're going to have to use the quadratic formula on to solve it. And you'll be able to pinpoint those on their graphs because you'll see that one of the zeros will probably be a nice whole number, or at least a rational value, and then the other two cross at some unknown values that aren't on your list of rational values that you started with there. Cheers.